Fusion Mobile, quality e-learning experience on the go.
Standard logic gates. We want to now introduce ourselves to logic gates. What are logic gates? That is not the gates to your school, nor the gates to your house. Logic gates include the inverter, and, or, NAND, NOR, exclusive OR, and exclusive NOR gates. Logic gates are the primary building blocks of every digital equipment. With these gates, it is possible to imply the simplest logic between two binary digits. There are 8 logic gates which are used extensively to control any kind of equipment or to perform any kind of operation. These logic gates, as we mentioned, are the inverter, the AND, the OR, the NAND, the NOR, the exclusive OR, and the exclusive NOR. Now, this might sound a little scary, but don't worry, we're going to explain what these things mean. As you can see here, we see the symbols for each of these gates. What a gate implies is this. When you have two inputs from A and B, what will be the result as C? For example, suppose A is on and B says off. What should C, that is the result, do? As you can see here, we see the on, off, and on of AND. As you can see A here, we see B here, and we see the result here, AB. So as we go on, we're going to learn how each of these function. Now, this is the AND gate. The AND gate, as you can see here, is represented with this. In the past, this symbol was used, but not right now, we now use mainly this. But how does it function? Well, as we look at the table below, we want to understand that 0 stands for off and 1 stands for on. Now, imagine you are in a house and you have one light bulb above you and you have 2 switches, one by the door and one by the bed. What happens if the switch at the door, which stands for A now, is off and the switch by the bed is on? That is how logic gates function. For example, for the AND gates, when A is 0 and B is 0, that is, when the bed is off and the door is off, the result is always off. But again, when one of them is on while the other is off, the result is off. So that means that the AND logic gate shown here offers a 0, that is off, when either of the inputs, either A or B, is off. It only shows an on or a 1 when A here is 1 and B is 1. We now want to look at another gate, that is the OR gate. We can see the symbol for the OR gate that is used primarily today. We can see the one that is used in the past. Let's again go back to your bedside. That is, you have your switch by the door and the other switch by the bedside. You want to off the light bulb. What will happen if you switch off the one by the bed while the one by the door is on? Well, the OR gate has an on when either of the inputs, that is A or B, is on. As you can see here, it has on in 1, on 2, on 3, when either A or B is on. The only time it is off is when both A and B are off. Now let us look at the NAND gate. The NAND is just an AND gate with an N before it, and N standing for not or negation AND. As you can see in the symbol here, the NAND gate is represented with a similar symbol to the AND gate, but then with a small circle before it. That small circle is the negation, the not sign. And as we can see, the symbol again, the A.B of AND, is now having a prime, that is an inscription 1 on top of it. That is the symbol for the NAND gate. Now, what does it mean? It means that everything the AND gate does, the NAND gate does the opposite. For example, according to the AND gate, when there are 2 offs, it shows an off. When there is 1 off and 1 on, it shows an off. But in the NAND gate, when there are 2 offs, it shows an on. When there is 1 off and 1 on, it shows on, either A or B. It only shows an off when both of them are on. Now, as we go on, we're going to find out that a NAND gate is the same thing as the negation of A and B now odd together. That is A and B plus together. Let's now learn more about the NOR gate. The NOR gate, like the NAND gate, is a negation not of the AND gate but now of the OR gate. As you can see, they have similar symbols, but right here we see that the OR gate has the same similar circle as the NAND gate, which represents negation. The NOR gate shows zeros where the OR gate shows 1, and shows 1 where the OR gate shows 0, as you can see in the table here. So when the two sides are off, when A and B are off, we have on. When A and B are on, we have off as a result. And when either A or B is on or off, we can see 0, that is off. Now, this is the symbol for the NOR gate. It will also be good to know that the NOR gate is also a negative AND, that is negating A and B and then ANDing the two of them, that is multiplying the two of them, will give you a NOR gate. The exclusive OR gate is a special gate. As you can see in the diagram here, it looks like an OR gate but then has a small bar before it. The XOR, as it is called, has a logic that shows off when either both of them are off or both are on, but shows on when only one is off and only one is on. As you can see here, the symbol is a plus sign in a circle. Let's also now look at the exclusive NOR gate. The XNOR, just like the other negations, is just a negative form of the XOR gate. As you can see here, it shows 1 when either both of them are off or both are on, but shows a 0 when either one of them is off and on. Let's now discuss the uses of logic gates. Take for example that a building has a doorbell. What happens when one is pressed in the front door and the other one at the back door? Let's take some examples. When we have two buttons that activate the same doorbell, if you push the button at the front door or the one at the back door, the doorbell will ring. That is an OR gate. When we have a basement, where one switch at the basement or a garage turns off the lights and another switch upstairs turns on that same light, this is an implication of OR logic because you can operate the lights by the downstairs switch or the upstairs switch.